This is Algebra 2, Unit 9, Lesson 2 on complex numbers. All numbers fall into a very broad category known as complex numbers. Complex numbers can always be thought of as a combination of a real number with an imaginary number, and it has the form a plus bi. The a part is the real part, and the bi is the imaginary part. So you can't combine these. It's like saying 6 plus 3x. You can't combine those because they're not common terms. You have to make sure that you can add real to real and imaginary to imaginary when you're doing these. So the key to these operations is that real components combine with real components and imaginary with imaginary. So it's just like working with variables. Think of the I as a variable because it kind of is. You want to add the real numbers together and you want to add the complex or the imaginary numbers together. So if I regroup these, negative 2 plus 7i plus 6 plus 2i, I can regroup these so I have negative 2 plus 6. Those would be the real. And then 7i plus 2i. Now, yes, you can do this in your head. That's perfectly fine. But I just want to show you that these are the reals and these are the imaginaries. So when I combine them, negative 2 plus 6 is 4. 7i plus 2i is 9i. So this sum is 4 plus 9i. All right, so let's try this sum. 8 plus 4i plus 12 minus I. What is the value of the real part of the expression? Well, 8 plus 12 is 20. And the imaginary part would be 4i, and negative I would be 3i. Okay, now, just like doing polynomials, real and imaginary numbers, the subtraction rules still apply. When you have to do subtraction, remember you have to distribute the negative through the parentheses. So this is actually going to be 5 plus 3i minus 2 plus 7i. All right, combining your terms, the real part would be 5 and negative 2 is 3. The imaginary part, 3i plus 7i, is 10i. All right, one more. We have to subtract these, so we have to carry the minus through the parentheses. Negative 3 plus 5i. Minus 8 becomes plus 8, and then minus 2i. Combine your terms. The real part, negative 3 plus 8 is 5. 5i minus 2i is 3i. So adding and subtracting with real and imaginary numbers works the same way as if you were doing it with polynomials. So let's do this last one with adding and subtracting. Which of the following represents the sum of 6 plus 2i and negative 8 minus 5i? Well, sum means we're going to add them, so we add real to real. 6 plus negative 8 is negative 2, plus 2i minus 5i is negative 3i, because these two are the imaginary. So this is actually negative 2 minus 3i, which is going to be number 2. Okay, now adding and subtracting complex numbers is very straightforward because the process is similar to combining algebraic expressions that have like terms. The complex numbers are closed under addition and subtraction. Basically, if you add or subtract two complex numbers, you're going to end up with a complex number. But let's look at multiplication. Is multiplication going to be closed? Well, let's take a look at what we have here. Find the following products. Write each of your answers as a complex number in the form a plus bi. All right, so if I want to multiply here, this is 3 plus 5i times 7 plus 2i. It looks like two binomials, because it is. So how do we multiply two binomials? We FOIL. 3 times 7 is 21. 3 times 2i is 6i. 5i times 7 is 35i. And 5i times 2i is 10i squared. Okay. Now, it says write each of your answers as a complex numbers in the form a plus bi. All right, now before we do anything else, we have 21 plus 6i and 5i, 6i and 35i, excuse me, is 41i. And then we have 10i squared. Now, what did we learn in the last lesson what I squared means? Well, we know I is equal to the square root of negative 1, so I squared is going to be the square root of negative 1 squared, which is negative 1. So we can substitute in I squared as negative 1. So this is 10 times negative 1, which will be negative 10. So 21 plus 41i minus 10. combine these, 21 and negative 10 will give me 11 plus 41i. So if you have an I squared or anything other than I in the problem, you need to simplify it. All right, so this is an A plus BI form. All right, let's FOIL this next one. First is negative 2 times 3 is negative 6. Outside, negative 2 times negative 2i is positive 4i. Inside, 6i times 3 is 18i. And 6i times negative 2i is negative 12i squared. All right, now combining my terms, I know that I squared is negative 1, so this is going to be negative 6 plus 22i minus 12 times negative 1, which is going to be positive 12. So negative 6 plus 22i plus 12. 12 and negative 6 is 6 plus 22i. All right, last one. 4 plus I times negative 5 minus 3i. First is negative 20. Outside, negative 12i. Inside, negative 5i. And last is negative 3i squared. All right, now we know that I squared is negative 1, so we know this is going to be plus 3, because it'll be I squared is negative 1 times negative 3 is positive 3. Negative 12 minus 5i is negative 17i. And then negative 20. Combine your terms, negative 20 plus 3 is going to be negative 17 minus 17i. Okay, be very careful of this, because remember that I squared is negative 1, and negative 3 times negative 1 is positive 3. I just did it in my head right here. Okay, now let's consider the more general product, A plus BI times C plus DI, where constants A, B, and C, and D are real numbers. Show that the real component of this product will always be AC minus BD. So what I want to see is when I multiply this out, the real part of this is going to be AC minus BD. Let's see if it is. Well, it's going to be A plus BI times C plus DI. All right, so first is A times C. Outside is A times DI. Inside would be BC times I. And then last will be BDI squared. All right, now remember I squared is negative 1. So this is going to be AC plus ADI, sorry, looks like a C, plus BCI plus BD times negative 1, which would make this negative BD. So combining my terms here, the ones that I can combine are the AC and the BD because they are real numbers without an I on it. So AC minus BD plus ADI plus BCI. Now, if we want this in the right form where we have a single term, we can think of this as the real part and this is the imaginary part. We can actually factor out the I. So this is going to be AC minus BD plus AD plus BC times I. I just factored out the I and put it on the end. So first term plus our imaginary real term plus the imaginary term. All right, so we multiplied these imaginary numbers and we end up with the real part is always going to be AC minus BD. Show that the product of 2 plus 3i and 4 minus 6i results in a purely real number. All right, so let's see what happens. When we multiply this, we should end up with a real number. All right, first term is going to be 2 times 4 is 8. Outside is minus 12i. Inside is plus 12i. And last is minus 18i squared. All right, now we know these two are going to cancel each other out. And then I have 8 minus 18i squared. But remember, what did we say I squared was? I squared is negative 1. So this is negative 18 times negative 1. 8 plus 18 is going to be 26. All right, under what conditions will the product of two complex numbers always be a purely imaginary number? Check by generating a pair of complex numbers that have this type of product. So if we're looking at A plus BI times C plus DI, which came out to be this, how can we make this be only imaginary. What part of this would have to be not there? Well, the AC minus BD would have to be not there. How could we make it not there if that was equal to 0? So if AC minus BD is equal to 0, that means that AC will equal BD. All right, now let's try this out. I need something multiplied, A times C and B times C, that is the same, but with different numbers. What would be a good one, A times C? Let's say 12. So let's say that AC and BD both equal 12. All right, so what could we make for A and C? Well, let's make A 2 and C would be 6. 2 times 6 is 12. And then B times D. Let's say B is 3 and D is 4. All right, so if we write them in the form A plus BI times C plus DI. All right, so A plus BI would be 2 plus 3I. And then C plus DI would be 6 plus 4I. Okay. Oh, all right, so C plus DI. All right, so let's work out the product and see what happens. 2 times 6 is 12. 2 times 4I is 8I. 6 times 3I is 18I. And then 3I times 4I is 12I squared. All right, so we know this is going to be 12. 8 plus 18I is going to be 26I. And then 12 times I squared is actually 12 times negative 1, which makes this negative 12. So what happens to the 12s? They're going to cancel each other out, and you're left with purely an imaginary number. All right, so what we have found is that when you add and subtract complex numbers, you're going to end up with complex numbers. But when you multiply, you can end up with a complex number, or you can end up with a real number or an imaginary number, depending on what your values are when you're multiplying. All right, let's determine the result of the calculation below in simplest A plus BI form. All right, so we have multiplication here in two different forms. We have FOIL and we have distributive property. So let's do both. See if you can work it out and get it to work, and I'll also do exercise 6 just to wrap it up.